Nice to see you all back again and giving us your time to learn more. Our next speaker, ladies and gentlemen, was just saying, gee, John, what does a community engagement manager do at Jetcharge? And I guessed, of course, that it just means you get more phone calls transferred to you from community groups that you probably don't want to talk to. But Zoran has maximised that. He's an experienced development business manager with a demonstrated history in the EV industry. He's skilled in customer service, management, sales, strategic planning, research and development, prototyping and presentations, and, fortunately, public speaking. Please welcome, ladies and gentlemen, the community engagement manager at Jetcharge, Mr. Zoran Bravo. Big hand.
We're streamers. Animals, you need to control yourselves. This is an EV Expo after all. So, yes, what is that, a septuple threat in terms of the things that I do around the EV space, but I'll do the spiel. And yes, so my name is Zoran Bravo, and yes, I'm the community engagement manager, but first and foremost, I'm just absolutely passionate about EVs, but also its associated technologies. It's one of those fortunate places I find myself where I get paid to do this. And if I didn't, I'd be in my garage doing it anyway. So the very reason that we're here to talk about, well, the emerging innovations that are coming to market, they're just like with EVs, it's imminent. It's just a matter of just sort of setting the expectation so we know, oh, right, why didn't I know about this? So let's just move here. Is this working? There we go. So a little bit about Jetcharge. I've been instructed. We are sponsors, so I must plug away. If you're not aware already, Jetcharge are not only installers, we're distributors, but also managers of electric vehicle infrastructure. And this scope ranges as broad as you'd like it. It could be right down from your humble domestic install, right through to enterprise, and of course now with national infrastructure being rolled out at rapid pace, chances are we're there. So with that also, I mean, we've been doing it for a little while. We've managed to not only do it for private interest, but now we've also managed to integrate ourselves with over 10 of the official major vehicle brands in Australia. So if you're shopping for a car, chances are we've worked with that manufacturer to help deliver the most appropriate solution. Same with Tesla. Even though we don't supply the charger, chances are we're helping you achieve the best possible result with that infrastructure. During our time, so right now, by the end of 2019, we would have installed more than 3,000 charging stations, which is by far the most amount of infrastructure by any one entity in Australia outright. And when you do that, you tend to garner quite a bit of experience as you do that. So further to that, we also found the genuine need to launch a homegrown software solution pertaining to the ability of being able to control billing, access and visibility of these stations too. So we teamed up together with company Cogent to launch what we now know as ChargeFox. And as a result, we work very, very closely as a result. So two essentially sibling companies now, one with the hardware, other with the software, and that's how we roll in the industry. A little bit more about diving into the sectors that we work in. So there are four major areas that we work on in the EV space. So we see ourselves as an end-to-end service provider. So when we talk about, say, the domestic market, we're talking about the chargers in your garage, at your home. At this rate, and I'm still processing this information, we're doing 15 installs a day nationally. With the current trend, especially with the advent of Model 3 and more offerings coming from manufacturers, we're on a trajectory of 20 installs per day. So we have a dedicated team to our installs, coordinating with our own and also contracted resources. I said that's just mind-boggling when you consider the moving parts involved. Every home is bespoke, different capacities, renewables, and the like. On the commercial side, we're mainly working with fleet operators. So we're trying to ease that transition from the traditional model of combustion engine cars cutting over to electric, so making that as pain-free as possible. And together with that, also property developers. And that's at varying stages. So it could be at the planning stages, right on the plans, or even retroactively, where EVs were never really scoped into the design, but then we sort of work with the resources that are available. Then the other one, which some of you may already be aware of, the public aspect. So once again, as I started with ChargeFox, we would provision the hardware, we would install the hardware, and then would hand over to ChargeFox, who would then take care of the billing, management, and all of those customer-facing service functionalities. And of course, anything ongoing with that, support and the such. And finally, apartments. Real tricky one, especially if you're subject to an owner's corp or a owner's corp or body corp. A lot of the times, again, retrofits, trying to make, basically removing any perceived burden of being in an apartment and being restricted to bylaws or anything like that. We work directly with those bodies, tenants, again, to make not living in an apartment a penalty to not being able to go electric. So we try to make it as easy for all the sectors as best we can. Now, we are going to go over three main concepts, but where we're just sort of plant the seed as to what drives us behind it. We're not talking about how fast we can charge a car. We can do that pretty quickly already, but we haven't got cars that will consume that just yet. You know, we've got ultra-rapid chargers around the country. What we're talking about is how many, because the difference between actively standing at the pump and then plugging your car and walking away, it just changes the whole dynamic completely. So this is the sort of context that we're playing to, so you can understand where this is coming from. All right, so on that, if we look on the left, we've got an example of that's a pretty big-sized service station or fuel station. So we're talking about 20 Bowsers, and as we're all well aware, there's an active process involved. One, you've got to get there. You've got to take the nozzle out. You've got to fill. You're still present. You're very much engaged. Once you're done, the reverse, pay, go to your car, leave. And then the next person takes their place. And then the only way we can really quantify then is the throughput. How many people can we get through in, say, an hour? Whereas if we take the example on the right, this is an aerial view of, say, a shopping centre. We're talking about the same patch of land, if not smaller, but we're not restricted to a single plane. We've got a vertical here. So now we go from being able to service, say, 20 cars simultaneously at any one time to going to hundreds of cars in a facility such as a car park. And we'll get to the dynamics of power delivery as we go along. So that's how we're looking at things, because when people go shopping, they first have to engage in an active task, which can take anything from the transport delay to the active task to the leaving. Then they do their shopping, or they do it as a passive task. They plug in, they forget about it, and they come back to it. So on that note, when you're bringing in, say, hundreds of cars, the biggest problem is power. We're still dealing with lots of legacy infrastructure, and if we're talking about the old method of thinking, say 5 years ago, if I say I need to energize 200 car spaces, we would think, okay, this is far, far too expensive, because we look at the max potential load, have to supply that, then we start talking about utility scale rates of supply. It's highly inefficient on a cost basis. So enter energy management. So what is energy management? Well, in the case of energy management, what we're talking about here is not to be confused with load management. We may have heard that a bit, where we might have a string of chargers, and between themselves, they'll sort themselves out. You give them a limit, and they'll promise not to go over that rate. And it's quite isolated the way that they behave. It has no real impact on anything else. They just conform to the limit that's been imposed. Where we see things going is much like this example here. So this is AGL's head office in Melbourne. And the model here is replicating much like the model overseas. All the cliched references to the Scandics, from Stockholm, now we've got, just going south, you can go down through to Spain. The car parks would appear to have what would seem like hundreds of car charging options, but you don't see so many of those EVs. It's not suggesting that you're going to have 100 cars all plugged in at the same time. The idea is that you're just simply parking a car, and if it happens to be electric, you can plug in. But also playing to that worst case, should they all be plugging in, we can not only load manage all of those chargers, but we're also looking at what the building is doing as a whole. So we're not just factoring in just the cars, we're also seeing what's happening. Are there renewables? What's the current state of the grid? All of those, that's where we start talking energy management. The load management, just the component within it. So there are other smarts and logic that's taking place at the same time. So this is common overseas, and we foresee that this is going to start bleeding into the Australian market, very much in the case of fleet operators, corporates who just want to change their transport strategy, councils, great example. So that's something to look forward to. But then we also have building managers or building designers which come right off the line and say, and sort of lending to what I was just saying before, I want to make every single bay electric. I foresee cars of the future will be electric. Let's make everybody go electric. But if we were to use the wisdom of 5 years ago, again, I did mention this earlier, that would require massive, massive utility scale upgrades. Well, here, what we're trying to, we don't need to charge every car at full noise if it's going to be there for 8 hours, but we can service each car independently depending on its needs. So what we're trying to do is, based off the limit, be it from the grid or the site itself, we can say, right, everyone's connected, and as their states of charge or demand increase, we change with them. So we monitor each and every bay, every charger in this case, and then we address based on the environmental concerns. So if there is a grid impact, we might sort of taper down our maximum potential for all the chargers. So let's say hypothetically 22 kilowatts multiplied by 100, that's a lot of angry pixies coming out of the building, which also have to contend with air conditioning systems, business systems. So this system is not only enabling EV charging, it's also protecting the infrastructure itself. So it goes beyond just the charging. So how do we do that? Well, there's no real off-the-shelf product for that, so we set about creating one. So here is an example of such a system. It's all in Melbourne, made by engineers in Melbourne, made by coders in Melbourne, based off real problems in Melbourne and around Australia. And so this is our energy management system that would front end, or at least monitor, any given premises for this in mind. So again, if you've got renewables, great, let's consider that information. If you want to energize the entire car park, whatever the number be, and going to a little bit of a technical tangent, we're talking up to 65,000 cars if you're so forward toward the technology, or it might start at something humble and then scales up from there. Once implemented, the goalpost can shift as your world changes. So if you plan to employ renewables later down the track, or you already have, you want to maximize where your energy is going, that's where the energy management system, together with its load management functions and algorithms, can come in and cater to what's happening on the ground. So, what does this mean for everything else that's out on the market? The number one thing that you have to consider with this is, okay, we have versions of load management. We've heard it. There are iterations of it just for power in general. But how do we make it work on a broader scale? With our platform, what we're trying to set about is to make sure that it is as agnostic as possible, both on the software and hardware front. So if you've got one major manufacturer that has up to a certain point of time supplied, let's say, all of your electrical, or it's an embedded system, they would have a solution, and they've been around for a while, but then they sell off that technology arm to a third party, or it's diluted in some way. What happens to that model? Are you locked into that hardware platform? Or what if on the other side of software, what if the only way to make it work is you have to pay, I guess, a license, or you need to unlock that privilege? So by just going to the basics, we're using our system to communicate on a common protocol, and just saying, right, you're a charger from 10 years ago, you're a charger that's just been released, this is what's going to happen. We're all going to work in concert. And what that's meaning is that you might try a new technology that is hot right now. Maybe it doesn't work out in 5 years' time, but the energy management system, it pays no mind to that. It knows what it needs to do, and that is deliver energy as appropriate. So the number one key thing for us is definitely look at your agnostic solutions and what that means for you long term. We're in a market that is rapidly ascending in progress, and with that changes, new regulations, new feature sets. How will that play nice with the market as a whole? Now, a second innovation, which is really quite obvious, it's been around for a while, solar charging. I mean, why wouldn't you? It's a no-brainer, essentially. With our load management system, that we already know that we can acknowledge that, but now we have to factor in what it means to actually have solar. So yes, okay, you get it from the sun, quite right. Here's an example at Barnawatha, one of our ChargeFox locations. In fact, I passed this. I drove up from Melbourne, and not because I needed to, but I needed snacks on the drive. So this is actually not far from a service station. But whilst plugged in, with this 100 kilowatt array, that's 100 kilowatts of direct offset when the sun is directly over it. Of course, that tapers. But the idea is to maximize the yield of that solar, so consuming and tapering our utilization where possible. But then also what happens when it's nighttime? Then we incorporate batteries, acting as that ballast. So where there are no cars during the day, or if there's a lull, we're storing, we're collecting, and when we do have a visitor, we can just deploy with next to no impact to the grid, or working in concert with the grid, because we can also then incorporate some response if it's needed. So that's happening now, but just something to consider when you're next at a rapid charging station. Just have a look at the topography and just understand, what is that cabinet over there? Next thing you know, it's really impressive to see them at the ground level. You don't have to peek or climb up on a roof. It's all right there. So in the case of the Barnawatha North site, these are not small chargers either. So in this case, we're talking about 4 chargers in total, 2 of which would be classed as your ultra rapid, so 350 kilowatts, and then the 250 kilowatts. Either car on the market today could plug into either of them and still get absolutely great results, but this is future-proofing in action. Another example of this is City of Newcastle. And this is just one example of a few of their sites, actually, where we've got a series of counter-levered solar arrays or carports, and directly integrated with that, we've also, again, got EV charging, in this case a fast charger, and again, maximising when the sun's out. So if any cars are coming in from fleet during the day, perfect. If not, then it can compensate from renewables, or better still, even just offset peak demand from the grid. Speaking of the grid, so solar is great. It really is. It's one of the best transitions the world has been able to make with regards to energy as a whole. But then it also brings upon problems when it comes to the traditional way of thinking. One being, and I don't know if many of you have heard of the infamous duck curve. For the longest time, I look at it going, I don't see no duck at all. So for the sake of illustration, ignoring the orange solar generation, the curve is that dip in the grid. And if you were to superimpose a duck, which I didn't have time to do, I'm afraid, but the dovetail is at the left, and then that sort of goes up to the stem of the neck, and it becomes a duck. Just go with that. But what's happening is the dip in the grid is dropping, solar generation is going up. So what's happening? We've got a clean source, but then the legacy infrastructure before that, in this case coal or hydro, wherever it comes from, is ramping down in line with demand. So what's happening with those generators? They're spinning down because they've got to balance the grid. You've got to maintain a certain frequency. You've got to keep everything alive. So from here, we need to then concentrate on what we're going to do with the grid in terms of, where does this excess energy go to? We're generating. What if the car's not charging? So let's take Queensland, for example. Lots of solar in Queensland. To the point now where we have negative pricing on the wholesale marketing. Negative pricing. This is free power. So by incorporating energy and load management, we've just unlocked free fuel, essentially. That's what with these 3 innovations in total, that's the net result here. Because if we start trading these commodities, and we'll touch onto that with the 3rd innovation, we're talking about vehicles which were made for transport now becoming energy assets, which again we are going to go to vehicle to grid, which is, they're all interrelated if you think about it. So I don't know how many people have actually heard of vehicle to grid and know what I'm referring to. I mean, we're in an EV Expo, yeah. So also known as, there's a few iterations. You can say V2X, where the X is interchangeable with to the home or to the grid, and with that, it can be. There are a few other iterations in between, but that's the marketed ploy right now. and it works really well. With that, essentially, up until now, even when it comes to the electric vehicle, you're buying a car and you're calculating cost of ownership. Everyone becomes a businessman or a person. They go, right, I buy this car, my cost of ownership, my cost to run it. You do the math and it says, right, it's a quarter of the cost. Great deal. But you can actually go one step further, because you're not just buying a car anymore. You're actually essentially buying a battery with 2 axles. It's a really portable battery. And why not make that battery work for you for the house? You could have no solar and still have vehicle to home, but you could still be, sort of semi-autonomous when it comes to your power needs. But then with that, you also have the option to shift and respond to demands of the grid. So right now with solar, you would get maybe a few cents here and there for the good, clean energy that you make from the roof. But when we're talking at the wholesale market, when the grid might discover a shortfall, not because of EVs, but let's say because everyone needs that air conditioner on at full ball, middle of summer, your EV, which was an investment to get you around town, can now help facilitate shortfalls in the grid, which in turn you can get rewarded with at the wholesale level. We're not talking 20 cents a kilowatt hour, we're talking like $15, pending where that duck curve is in terms of demand. Higher the demand, higher the rate for the power. So, how do we do that? It's not here yet, but what we have here is a bidirectional charger. So right now, I believe Nissan, they've officially stated that they will honour their warranty with their battery and vehicle utilising this technology, and more will come to follow. So right now, this is going to, think of it as another wave of disruption. Right now, we're talking about a vehicular asset that is now not only disrupting the vehicular market with fuel, but also now disrupting the energy storage market. So we've gone from having stationary fuel stations, where now we've got stationary batteries, but now we have a battery which we can just wheel in and out. And what happens now to your power walls, for example, your Teslas? Great product, but you can't take that with you. That's bolted on the wall. The other thing too, it helps facilitate that transition of, do we own our cars? What can we use them for? So one concept which I'm not sure how many have heard is about the autonomy aspect, where the car can go off while you're in the office, do some ride share in full autonomy mode, and you just get a little notification, by the way, I made you $200, please wash me. Here, instead, the car can be completely static, plugged into the wall, and through the ebbs and flows of the energy market, which oscillate at a much more vicious cycle than, say, the share market, or if not in parity, it can trade, sell, within confines that you can dictate. Next thing you know, you've paid for your parking, your $16, you get complimentary charging, oh, but we just turned a profit. So something that really changes up the way that works. But then also, if we were to say, hypothetically, consider EVs as part of the grid solution, then we start running some really interesting numbers. Further to that, as I've made a note there, it also turns the likes of fleet operators, when the fleet's not active, into asset managers. They actually can start operating on the grid when the fleet's inactive. Here's an example here where we've got PV array with generation, and then we've got response when it comes to the market of energy. So most times, when people with storage at home, they've invested in that technology. Why would I want to sell my energy? I've invested in this tech, solar, batteries, thousands of dollars gone. Why would you want to use your car as an asset? Well, again, at the wholesale level, it's completely different to retail. We're not talking 11 cents. So if you go, I have a 40 kilowatt hour car and there's a shortfall in the grid, you go, right, you need help. How about you take 10 kilowatts from me at 7, and this is automatically done in the background, at $7 a kilowatt. You just paid for your power bill and you got a free charge in the process. Now let's just run some numbers on that. Let's say hypothetically, what is our uptake now? We're still sub 1%. For the sake of argument, and let's not quote these as full statistics, but just so you can get an idea of the headspace. Let's say we have 10% uptake and that equals 100,000 cars. Let's also assume that maybe each one of these cars has the capability to transact that power back and forth at will. Now you take the capacity of the car as an average, we're talking about 4 gigawatt hours of energy stored as accessible. We can compare that to 100 megawatts of a static battery out in Adelaide, which can also discharge at 100 watts on demand, so it's a 1-to-1. But each one of these cars can transact present day, it'll increase no doubt, 7.5 kilowatts. Again, you multiplied that by 100,000 cars at 10%, and then we have an instantaneous supply of 720 megawatts. So again, now we've gone, it's two different ratios for the same solution. So now instead of going one-to-one with our storage to rate of output, we've now got this tremendous accessible resource which doesn't require spin up. It's already there. It can just react. So something to consider there. So now go back to the old logic, which I mentioned earlier. You have traditional car thinking where, okay, I bought the car, sits idle, it's only working when I'm sitting at the cockpit, or maybe they're just efficient batteries that are sitting, doing my bidding. So you combine those innovations, just those alone, you've essentially got free fuel. I'm hoping that's given you some insight as to where we believe it's going. Of course, nothing's set in stone, anything can happen, but a lot of indicators are suggesting that, and we have had a lot of interest with regard to bi-directional management systems. At the end of the day, until we know what's happening on the ground, we just try to be as ready and prepared as possible with solutions. So thank you so much for your attentiveness. Appreciate it very much. And if you've got any questions, feel free to visit us at our booth.
Fantastic. Thank you very much. How exciting for you working with